Good morning to all. Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group. Today we will discuss MQTT methods, and components. That is the unit inside subject IT 703B, that is Internet of Things, or SEM. So let's start. First is the MQTT. Main is what is the MQTT? What is the full form of MQTT? That is the Message to Telemetry Transport Protocol. MQTT is an OSI standard message protocol for Internet of Things. It is designed as an extremely lightweight publish and subscribe message transport that is ideal for connecting remote devices with a small footprint and minimal network bandwidth. This is the beauty of the MQTT. It is a lightweight protocol, publish and subscribe, message transport, and mainly ideal for the connecting remote devices with a small port and minimal network bandwidth. MQTT today is used in a wide variety of industries such as automotive, manufacturing, telecommunications, oil and gases. Remember one thing in the last session, we will come to the applications of the MQTT. So you have to make a concentration here that it is used in industries, that is the automotive, manufacturing, telecommunication, oil and gas. MQTT is an open OSIS and ISO standard, lightweight, publish subscribe network protocol that transport message between devices. The protocol usually runs on over TCP/IP. However, any network protocol that provides ordered, lossless, bidirectional connection can support MQTT. Some more regarding the MQTT. MQTT is an open source protocol that is very important for passing messages between multiple clients through a central broker. It is designed to be simple and easy to implement. The MQTT architecture is a broker based and use long-lived outgoing TCP connections to the broker. MQTT are also support hierarchical topics. Now, MQTT can use for the two-way communication over unreliable networks where cost per transmitted bit is comparatively high. It is also compatible with low power consumption devices. The devices will consume the low power. It is also compatible with that. The protocol usually runs over the TCP/IP. I will discuss in the last slide. Now, this was that we have discussed the MQTT, two-way communication or unreliable networks. The protocol is lightweight, simple, therefore well suited for the constrained environment. Now, MQTT has a mechanism for asynchronous communication and for communicating disconnect message when a device is disconnected. The most recent message can also be stored and forwarded. This is the beauty of the MQTT. If your device has been disconnected and when the device will connect, then at that time the most recent message they can be stored and can be forwarded. There are multiple versions of MQTT. We will discuss them later. Now, the MQTT only partial interoperability between publisher and subscriber can be guaranteed because the meaning of data is not negotiated. That is very important. Meaning of data that should not be changed, especially in the IoT scenario. If the data that has been changed, when the meaning of data has been changed, then you can assume that what will happen. Client must know the message format upfront. In addition, it doesn't support labeling messages with type or metadata. This MQTT that doesn't support labeling messages with types or metadata. MQTT may include large topic strings that may not be suitable for small packages of some transport protocol. TCP may negatively affect the network efficiency as the number of nodes connection to the broker increases. Okay, this is the some negative effect of the TCP. If the number of nodes is greater than 1,000, poor performance and complexity may also result because automatic dynamic discovery is not supported by MQTT. Because the protocol is designed to be simple, user must decide whether it is too simple, susceptible to potential hacking. Now they were there in this slide. We discussed some drawbacks of the MQTT and the drawback of the TCP/IP. As the major drawback, that the MQTT is very simple, so there is the hacking may be possible. Automatic dynamic discovery is not supported by MQTT. Second, and regarding TCP, when network efficiency becomes poor, when number of nodes increases. Now the message queue telemetry transport MQTT is a 2013 standard form B. That is the standard from the Organization for the Advancement of Structured Information Standards, that is the OSS. The MQTT came from OSS in 2013. It was introduced back in 1999 by the IBM. It provides the connectivity between applications and user at one end and network and communication at the other ends. Now, in the publish-subscribe architecture, the system consists of the three main components. This is very important. This is very important, and one important thing that we have discussed, that is the full form of the OSS. That is the Organization for Advancement of the Structured Information Standards. It is a published subscribe architecture, that is the MQTT, where the system consists of three main components. First, that is publisher. Second, subscriber and broker. Publisher, subscriber, and broker. Let's see what is publisher, what is subscribers, and what is broker. In IoT, publishers are the lightweight sensors that connect to the broker to send their data and go back to sleep whenever possible. What are the publishers? These are the lightweight sensors. These are the nodes that connect to the broker. The sensor, they are connected to the broker, and broker will send data to the subscriber. The subscribers are applications that are interested in a certain topic or sensor data, so they connect to broker to be informed whenever new data are received. First, we are done the publisher. What are the publishers? Publishers are the lightweight sensors that connect to the broker to send their data and go back to sleep whenever possible. The subscribers are applications that are interested in a certain topic, or sensor data, so they connect to brokers to be informed whenever new data are received. They inform the broker that the new data has been received and connect to the broker. The broker, last. The broker classifies sensor data in topics and send them to the subscriber interested in those topics only. So in publish subscribe architecture, the system consists of three main components. How many components? Three components. First, publishers, subscribers, and brokers. Publishers are the lightweight sensors that connect to the broker to send the data. Okay, and after sending the data, they go back to sleep whenever possible. It is if there is a possibility that they can go to sleep. Subscriber, what are the subscribers? Are the applications that are interested in a certain topic and sensor data, so they connect to brokers to be informed whenever new data are received. And broker classifies sensor data into topic. This is the one responsibility of the brokers. Classify the sensor data in topics and send them to the subscriber interested in those topics only. Only the topic related data has been sent by the brokers to the subscribers. The MQ, that is the telemetry Mqtt protocol, is another communication protocol designed for end-to-end communication based on the TCP/IP. M2M means machine to machine. TCP, transport control protocol, and the IP, that is the internet protocol. Now, this is the Mqtt architecture. As we will discuss, that is the publisher, subscriber, and broker, three main components. So here the publisher publish the data, that is the here the temperature, and the broker, the data is stored according to topics, and data is sent to the subscriber on demand according to topics. There is the here the broker is in the center, and the subscriber, that is the server one, that is the client one, and client two, these are the nodes from where the data comes. Now the MQTT was developed by IBM in 1999. Someone of you are thinking that why we are repeating, because we are here going to discuss the MQTT, and I think so. When we go again and again in the topic, your mind will recall that what we have done in the past. So here the MQTT was developed by the IBM in 1999, first thing, which is a publish and subscribe protocol. Second thing, it runs over the TCP/IP. The client acting as publisher and subscriber connect to the server, which is a message broker for receiving notifications. MQTT is used for remote locations where limited network bandwidth is required. Different clients can subscribe to a central broker for accumulating topic created by the devices in MQTT, which employs a message exchange model. This message exchange model is resource proficient and does not follow a specific data structure. A client receives a message from the broker. The simple, a client receives a message from the broker which it subscribes to about a topic when a message is posted by the device. Device, that is the publisher, that is node. The purpose of the broker is to inform. The purpose of the broker is to confirm message delivery by simplifying management and facilitating IoT devices connected through the network. What is the purpose of broker? The purpose of broker is to confirm message delivery by simplifying management and facilitating the IoT devices connected through the network. MQTT is well suited for machine-to-machine communication following a lightweight messaging protocol. It also provides the security even if the connection breaks off for a transmitted message by resolving the glitches with the untrustworthy connections. It means the MQTT is helpful when there is the unreliable connections, untrusted connections are there. This problem can be resolved by the MQTT. This is the MQTT architecture. As we have discussed earlier, the MQTT architecture, that is the one is the publisher, it will send the message. Is the MQTT, the broker, take the message that is the and stored according to topics, and then broker sends the message to the subscriber as demanded, it is according to topics. This was again one more, because we have discussed the architecture in the, this is the third form that we have discussed, and this was the second form, and here this was the first form. My aim is to clarify you that is about the MQTT architecture in the simplified way. That depends upon you, that which this figure of the MQTT architectures will impress you. First it was, second the publisher, broker, and subscriber. Third is, that is the MQTT client. Here is the MQTT broker. Now see here, the MQTT client, there is the publisher, is the temperature sensor. Publisher, who will publish the data, is the temperature sensor. Publish to the topic, that is the temperature, right? And publish 24 degrees Celsius. From where the data has been published? From the temperature sensor. This is the MQTT client. It published the data. Here the MQTT broker. The broker published the data according to the topic as required by the client. That is the subscriber. Subscribe the data, send the data that is according to topic, and data has been sent by the broker. Okay, so here in this architecture, that is the publisher, broker, and the subscriber. Here is the clarity regarding that what they are doing. Here in this architecture, the publisher, broker, and the subscriber. So thank you. We have discussed regarding the MQTT and the components of the MQTT. Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group, Bhopal, welcomes you, and thank you for watching the video. Okay, thank you.